Hello friends, welcome to my channel Q Analysis, and today we are going to host this webinar on essential testing matrices for measuring quality assurance success. So for all those new audience and users who haven't subscribed my channel yet, I request them to please go ahead and subscribe my channel Q Analysis. In case if you're interested to learn more on software testing and quality analysis, you can go through the videos. Feel free to like, share, and subscribe if you haven't done so. And please hit the bell icon so that you get notified for any upcoming videos on quality analysis from my side. So let's start our today's webinar. In our today's webinar, I'll be covering few topics like why should you care about quality and software testing matrices? What are absolute matrices? What are derived matrices? Different kind of formulas, how to calculate different matrices, and then how to calculate the test effectiveness matrix, and then how to calculate test coverage matrix. So without wasting any further time, let's start with our today's webinar. So friends, most of the time you people see that whether you're working as a software tester, a test engineer, or let's say quality analyst, test lead, test manager, or a project manager, business analyst. So all of us at different roles at different point of time, we have to come up with an answer for question, what have we tested, instead of we have tested it, right? And in order to show what you have tested or what kind of testing has been performed, we have to come with a combination of data. We have to back our findings with some kind of data, convey the result, and formulate a kind of prediction, and everything should be backed up by data. The main goal of software testing matrix is to measure, track, and monitor your test activities. So this is the basic principle what we have to keep in our mind as and when we are going to use different kind of QA matrices and we are trying to measure the quality assurance success. Why should you care about QA matrices? Okay, there are certain questions which are being asked. May it be any kind of software testing professional, or may it be any kind of lead, business analyst, or managers or consultant. When you're performing a role, or when you're ensuring the quality, when you're saying that we are providing a quality product to our users or for our clients or for our customers, there are certain questions which could be asked to you, right? For example, how long will it take to test? How much money will it take to test? How bad are the bugs? How many bugs found were fixed, reopened, closed, and deferred? How many bugs did the test team did not find? How much of the software was tested? Will testing be done on time? Can the software be shipped on time? How good were the tests? Are we using low value test cases? What is the cost of testing? Was the effort adequate? Could we have fit more testing in this release? And on similar line, there could be lot many business and technology and software testing and quality related questions which you could be asked not only from your team but also from the developers, also from the manager, also from the different kind of stakeholders including clients. So in order to answer all this question, you have to come up with some kind of data points. You cannot just say, okay, if somebody is asking how long will it take for you to test, you cannot just go ahead and say 2 weeks or 3 weeks, or maybe I have to see, I'll let you know. No, this is not at all acceptable. You have to come up with some kind of matrix, some kind of data sheet, some kind of estimation, and even for that kind of estimation, you should have a historic data from the previous releases or maybe in the current releases. What exactly is your um, uh, velocity or burn down velocity or whatever things which you're using in order to predict, okay, in this amount of time this many test cases are executed and this much amount of defects were identified, or this much test cases were covered, this much quality was ensured. So something like that has to be given by your end. Focus and use of data for improving the test process rather than to show you fancy reports. So friends, this is the main point which you should care about. You should focus and use the data for improving your test process, improving your quality process, QA process, rather than to show just fancy reports and numbers. And then if you have data with you, you can easily answer any of these questions. Now, this QA matrices, they can be divided into basically two categories. First one is absolute matrix, and the second one is derived matrix. So what is absolute matrix? Let's go ahead and talk about what is absolute matrix. Absolute matrix are those absolute numbers which are used for your calculation or which is used for prediction or getting to a kind of result. For example, total number of test cases, number of test cases passed, number of test cases failed, number of test cases blocked. When I say blocked, they couldn't be tested because of some dependency or because of some technical issues or something which is because of which unforeseen circumstances because of which the testing couldn't be completed. Number of defects found, number of defects accepted. When I say defects accepted, means all those the defects found or defects raised and defect accepted are not the same thing. Defect found is something which you are finding as a part of your testing process, and then when you report it to developers or you report it to the product development team, they may or may not accept it depending upon what kind of issue it is, where it is impacting, what is the priority, is it directly related, it is indirectly, can it be deferred, was the requirement understanding proper, or maybe there is a gap between the software developers understanding and the testers understanding, or is it a business critical issue, or it is something which was already present and then may not be impacting the current release, so it will be moved on to the next one. So there are so many things depending on which a defect is rejected or a defect is accepted or a defect is deferred. So number of defects accepted, defects rejected, and defects deferred, number of critical defects, number of planned test hours. Like depending upon, this is very simple, right? For the total number of test cases what you have developed, on an average, how much each test case, let's say you have to come up with a complexity, and then depending on the complexity, you have to come up with a number, how much time it takes for doing one test case, and then you extrapolate it to a bigger set of test cases with a higher, medium, or low complexity, and then you come up with a number. It gives you a planned test hours. It is just planning. Actual might be different. So number of actual test hours, number of bugs found after shipping. I'm talking about the production defect. So once the release is being signed off, it has been rolled out in production, and it is being used by users, and at that point of time, if there is any user issue, is it attributed to QA? Are there any issues which should have been caught as a part of software testing process or as a QA cycle, but then it couldn't be identified, and then somebody else, maybe users or some other developers or somebody else, is finding it out while using the product in production. So these are example of absolute matrices. These are exact numbers which are used for identification of the current state. And then using this absolute matrix, you can find out a set of different matrices which are known as derived matrices. So derived matrices are a little more important. It is used for reporting purpose. It is used for higher management. It is used for communication. It is used for finding different kind of interrelated figures, values, and data. So what are those? Let's go ahead and figure it out. So example of derived matrices. I'll talk about 10 or 15 different kind of derived matrix over here. So let's go ahead and take one by one what is a different kind of derived matrix. The first one, average time for development team to repair defects. So when you want to calculate how much time on an average is taken by development team to repair defect, total time taken for bug fixes and number of bugs. So let's say you can take it from Jira, you can take it from the status report, you can take it from daily execution sheet, total number of bugs that have been fixed by development team, and what was the total number. Depending on that, you can figure out, okay, once the development is complete, you can divide the total number of time taken for fixing bugs by the total number of bugs. It will give you the average time of development for fixing the defects. Our next matrix is past test cases percentage. So how to calculate the past test cases percentage? If we have the total number of past tests and then total number of tests executed, so number of past tests by total number of tests executed into 100 will give you past test case percentage. For example, let's say you have 10,000 cases. Out of 10,000, 9,000 have passed. So 9,000 by 10,000 into 100 will give you the past test cases percentage. Failed test cases percentage, it is on the similar line. Number of failed test cases by total number of tests executed into 100 will give you the failed test cases percentage. For example, in the previous one, I have taken 9,000 test cases were executed, out of which 1,000 are remaining. A total are 10,000 out of 1,000. Let's say 900 or something which are failed, and 1,000 are blocked. So you can do over here 900 by 10,000 into 100 will give you the failed test cases percentage. Similarly, for blocked, you can have the blocked number of blocked test cases by total number of test cases executed into 100. So in previous case, let's say we had 9,000 pass, 900 failed, and 100 blocked. So 100 by 10,000 into 100 will give you the blocked test cases percentage. Fixed defect percentage. So in order to find the fixed defect percentage, you have to defect fixed by defect reported into 100. So whatever is total number of defects, let's say you have 200 bugs which have been reported, out of which 100 have been fixed. And when I say defect reported, is the valid defect. I'm not talking about the whole list of defects. There could be a lot number of defects, but for a typical sprint, only those defects which have been accepted by dev should be mentioned over here. So let's say out of 200, 150 were accepted by dev for a sprint or a release, out of which 100 were done. So 100 by 150 into 100 will give you the fixed percentage defect. Defect fixed, let's say 100, and total reported were 150. So in this way, you can find out the percentage of fixed defect. Accepted defect. Just now I talked about there's a difference between the total defect reported and the accepted defect. Let's say the total defect was 200, out of which 150 were accepted by dev team. So over here it will be 150 by 200 into 100. That will give you the list of accepted defects percentage. Same way you have defects rejected percentage. For defect rejected are those which are not going to be fixed, which are not significant, which they are unable to reproduce. All those defects will be considered as defect rejected. So total number of defects which were rejected by total number of defects that were reported into 100 will give you defect rejected percentage. The defect rejected percentage should always be low. It should not keep on increasing. It should always be a little less, because it talks about, it is something which is very much directly indicates the quality of defect being reported by development software testing team. So if this number is higher, this percentage is higher, that means a lot of defects were reported which were not acknowledged or which were not accepted by development team. Means it will bring something, a bad name, or it will give a bad idea about the testing team knowledge, may it be domain knowledge or may it be technical knowledge. So always there should be a focus on decreasing the defect rejected percentage. This number should always be minimal. And accepted defect percentage should always be high. Ratio should be 1. So defect accepted as a valid by dev team by total number of defects reported, this should be 100%. Something like that should be achieved. And defect rejected percentage should be minimal. It should be something like 0% or so. Deferred defects are the defect on which you don't have any contact, and they might be move on to the next release. So such kind of defect or the future release, or they're moved to the backlog. So such kind of defects which are not being fixed, they are accepted, but they are not fixed in that very moment or in that sprint or release, they'll be considered as deferred defect. Deferred defect for future releases by total number of defects reported into 100 will give you the percentage of deferred defect. Critical defect. This is very important. So as a part of our testing, software testing process, you report different kind of bugs. Some might be critical, some might be high, some might be medium, some might be of low priority. So all those critical defects which you have reported, divided by the total number of defects, give you an idea of critical defects percentage. So always focus on finding critical issues rather than finding high, low, and medium priority issues. So the main functionality which is under testing, a tester should always focus, or a business analyst or consultant, whosoever is performing the testing, he should always focus on finding critical issues. So it is good to have a high number of critical defect percentage. Average time to test a bug. It is something, the time taken by software tester or a QA analyst to test a bug fix, total time between a defect fix to retest all the defects. So total time taken once the defect was fixed, and then all those retests that have been performed on different kind of defects, total time between defect fix and time for retesting by total number of defects, give you the average time to test a bug fix. Number of bugs per test. Total number of defects by total number of tests give you an idea of number of bugs per test. So let's say you have 10,000 test cases and you're finding only 10 defects. So number of defect is equal to 10, number of test cases is 10,000. So you can see, okay, a lot many test cases are executed and only 10 defects are identified. So either your test cases is very elaborative, you need to reduce it, or you have to do some risk-based kind of testing and reduce the size of your test cases, and you have to cover new areas so that new defects could be discovered. Bug find rate, or number of defects per test hour. Number of defects raised by total number of test hours will give you the total number of bugs found in per test hour. Test review efficiency. The number of tests reviewed by total time taken for the review gives you the test review efficiency. Test design efficiency. Number of tests designed and total time taken divided by total time taken gives you the test design efficiency. So how much time it took for designing a single test case. Similarly, how much time it took for reviewing a single test case. Number of tests run per time period. Number of tests run by the total time taken for the test execution. It will give you an idea of per test case execution time. So these are different kind of derived matrices which you can take care of, and there might be more. All you need to do, depending upon different kind of absolute matrices, which I have discussed in my previous section, which was absolute matrix. So there are different kind of numbers of data points which you can use in different kind of formulas, either by dividing or multiplication or finding out the percentage. Then you can derive different kind of matrices as mentioned over here. With this, we come on to our next topic, which is a very important one: how to calculate the test effectiveness matrix. Now, what is test effectiveness? When you are asked how good you are at testing, or let's say, are we running high value test cases? What is the measure of bug finding ability or quality of test set? All these questions can be answered by finding or by calculating the test effectiveness matrix. So how do we calculate the test effectiveness matrix? I'll tell you with an example over here. Total number of bugs found in test, okay, by total number of bugs found in test plus bugs found after shipping into 100, it gives you the idea of test effectiveness. Let's discuss it in detail. Bugs found in test. When I say bugs found in test, means all those valid defects which have been identified by software testing, QA team, or business analyst as a part of testing, and which was accepted by development team. Yes, it is a bug, and they might have fixed it or deferred it, whatsoever it is. So all those issues which have been identified while test, maybe unit integration or regression testing or whatsoever, total number of bugs which were identified by a testing team while testing a product, divided by this number of bugs, that is total number of bugs found in test by testers, plus the bugs found after shipping. So let's say 15 days or 2 weeks or 4 weeks, it depends on company to company and their SLA. So let's say 2 weeks after the release has been gone into production, if anything which is coming into queue, coming in as a production defect, then and if it is attributed, it could have been identified in a QA cycle, then it is attributed to QA. So all those kind of defects plus total number of defects identified by testing team, when you sum it up and you have the bugs found in test divided by this bigger number, it gives you an idea of your test effectiveness matters. For example, there was 50 bugs identified by testing team, and then 50 bugs were already identified and 5 bugs were identified in production. So 50 by 55 into 100, it gives you 90.90%. This is your test effectiveness. A testing team or software development team should always focus on increasing their test effectiveness towards 100%. That should be their primary goal. This is a very important metric. Friends, always keep in your mind that your test effectiveness should be highest, should always move towards 100%. Now, with this, we come to our next topic, which is going to our last topic for the day. That is how to calculate test coverage matrix. Test coverage is something, how much of the application was tested. If you have to answer this question, how much you have tested, how much application has been tested, what is the coverage? When you have to answer such kind of question, you have to come up with test coverage matrix, and you have to come up with some data. And how to calculate this data? Executed test cases or test execution coverage percentage. You can calculate it by number of tests run by total number of tests to be run into 100. So let's say total number of test cases that have been executed out of 10,000 are 9,000, and then total number of tests to be done was near about 10,000. So how will you calculate the percentage of coverage? You calculate it by 9,000 by 10,000 into 100. It gives you an idea. 90% of test cases were executed and your coverage is 90%. Okay, friends. With this, we come to the end of our presentation. Myself, I am Prashant Kumar. I'm a QA enthusiast, and you can get in touch with me via LinkedIn or Twitter or through my channel. This is Q Analysis or my blog. Feel free to like, share, and subscribe. Do let me know your questions, queries, and comments. And I'll try to come up with all the answers and help you with my knowledge on quality analysis. Okay, guys. See you in my next presentation. Thank you. Take care. Bye-bye.